So this one is a very important one, and you see we have 3 marks question for this one. And the most important part of this one is not the concept itself, but rather the mathematics. So what do we need to find? We need to find the magnitudes of velocities VA and VB after the collision. VA and VB after the collision. So what should be the process to find these velocities? What should be done to begin with? The thing is, we can apply the law of conservation of momentum. Okay, we can safely apply the law of conservation of momentum. And once we apply the law of conservation of momentum, we can find these velocities, VA and VB. So the only tricky part is, now after the collision, the spheres or the objects are not moving only in x direction or in y direction. They are moving in the middle. So they are having 2D motion, two-dimensional motion. They're covering some distance in x direction and some distance in y direction. So whenever we get a situation like this, what is our way out to get rid of this situation, to get rid of this problem? We did the same thing in projectile motion, and we do the same thing whenever we have a force that is not horizontal or vertical, rather somewhere in the middle. How do we sort out this problem? These equations for the momentum only work if you're moving in a straight line. But if you're moving in 2 dimensions, in x-axis as well as y-axis, then we cannot use these equations as it is. So same was the case for the projectile motion. The equations of motion work only if the object is traveling in a straight line and with uniform acceleration. But in projectile motion, the object was not traveling in a straight line, and the way out of that problem was we broke down the motion into x direction, and we dealt that motion separately, and we also broke down the motion into y direction, and we applied the equations separately along the y direction. So we're going to do the same thing over here. So we're going to say momentum before collision and momentum after collision are equal, first in x direction and then in y direction. First along x-axis and then along y-axis. So I'm going to raise everything from here because I'll be solving it on the diagram. So let me raise off everything, probably except for the mass, because the mass would be used anyway. So first we are going with initial momentum equals the final momentum along x direction, along x-axis. So what is the expression for initial momentum? Initial momentum means the total initial momentum, A plus B. So the initial momentum was m, whatever the mass is, 1.67 into 10 to the power minus 27 mass times the velocity of A, and B was not even used because its momentum was 0. So the total initial momentum was the momentum of A plus the momentum of B, which is 0, this is the total momentum before collision. And what is the total momentum after collision but along the x-axis? Well, it is, matter of fact, we even formed the expression. You see, total momentum after collision along x-axis. We even formed the expression. So MVA cos 60 plus MVB cos 30. And the mass would eventually be cancelled out. So I'm not writing plus 0 because that would amount to nothing, equals M VA cos 30, sorry, cos 60 plus M VB cos 30. What is this? So this thing is the initial momentum before collision along x-axis, and this is the final momentum or momentum after collision along x-axis. And let me not insert the value for mass. I'm going to write M as it is. And you see, you find out why I'm doing so, because in that way I can cancel out mass on both sides. So you see, I'll be writing 500 M on the left side, and what do we have on the right side? I'm going to take M common, and what are you left with? VA cos 60 plus VB cos 30. And then you can cancel mass on both sides. So somebody please keep a check on the calculator. The equation that we would have is 500 equals VA cos 60, and the value of cos 60 is 0.866. 0.5. Oh, sorry, cos 60 0.5. 0.5 VA plus 0.866 VB. So this is one equation that we can use for the final answer. You can call this one as your first equation. Alright, but so far we cannot get the value of VA or the value of VB because we have two variables, but right now we have only a single equation. You can never find two variables from a single equation. So what do we need to do? We need to form the second equation as well. And how do we do? By forming the equation for the y-axis. So can somebody tell me? The answer is pretty straightforward. You don't have to calculate anything. Can somebody tell me what is the total initial momentum along y-axis? That is along x-axis. If your velocity is horizontal, if something is horizontal, if a vector is horizontal, its vertical effect would be 0, and if something is vertical, its horizontal effect would be 0. And now let me ask the same question again. What is the total initial momentum along y-axis before collision? Initial means before collision. 0. Excellent. The total initial momentum before collision is 0, because all the momentum before collision was horizontal. A momentum is a vector. Any vector that is horizontal has 0 vertical effect, and any vector that is purely vertical has 0 horizontal effect. So total momentum before collision, but let me write it down first. Now we are breaking down for y-axis. So the total initial momentum before collision along y-axis is 0, And what is the total final momentum along y-axis? This momentum. Okay, very good. So first we write down the expression. I can write down the expression first and then we can break it down. We'll make it simpler. Sine 60 plus mvb sine 30. Okay, where do we get these values from? From here. Okay, this is where we're getting these values from. Now the second thing is, let's recall the sign convention. Now we're dealing these vectors. We are dealing these things as vectors. Okay, so if we're dealing it these two things as vectors, the one that is directed downwards, should it be added or subtracted? If this thing is taken as positive, now we're dealing with the vectors. If this is a component, let's say 10, and the lower one is, let's say, 5.5. So how do we add these two? Should we be writing 10 plus 5.5 or 10 minus 5.5? Minus. So the one that is directed downward, because now we have to find the magnitude, we have to find the values, so we'll use the sign convention as well. So this one, which was directed downward, I'm going to put the negative sign with it, because this one would be negative. It is directed downward. So you can rearrange it. You take m common from these two terms and you divide it on the other side. 0 divided by m, you'll be left with 0. So 0 equals VA sine 60 minus VB sine 30. Okay, so I've done two things here. I've taken mass common, then I shifted mass on the other side, and it was 0 divided by mass. 0 divided by anything equals 0. Then let us insert the values. So this one would be 0 equals VA sine 60 is 0.866 VA minus 0.5 VB. So this is your second equation. So I'm going to highlight the main equations. This is your first one, and this is your second one. Now the choice is yours. Whatever way you want to solve the equations with, totally your choice. I don't want to restrict you to one of the method. There are plenty of ways. Elimination method, substitution method. You can even use the calculator. Even use the calculator directly to solve the simultaneous equations. How many of you know how to solve the simultaneous equations using the calculator? So right now, I'm going to solve it by method of substitution. So I'll need some place here, some space. So I'm going to write the two equations. Somebody please read the equations so I can write over here. The first one, 500 equals to 0.5 VB. Okay, and then plus 0.866 VB. And the second, Okay, so what I'm going to do is I'm going to plug the value of VA from the second equation. So I'm going to rearrange the second equation for VA and going to plug the value of VA in the first one. So if I rearrange the second one, it would be written as 0.5 VB equals 0.866 VA. Okay, and then VA equals to what? VA equals 0.5 VB divided by 0.866. Now VA equals, somebody divide these two things on the calculator. 0.577 VB. So the value of VA in terms of VB is 0.577. So I'm going to insert this value of VA in the first equation over here. Okay, so the first equation would be written as 500 equals 0.5, and then I'm going to insert the value of the new value of VA, which is in terms of VB, 0.577 VB. This is a value plus the next thing, each and everything as it is. All right, so we have to solve this using the calculator. So first thing, 0.5 times this, what do we get? 0.288. Okay, 0.288. Yeah, that would be enough. VB plus 0.866 VB. So these two are the like terms, they can be added. So 0.88 plus 0.866, what do we get? 1.154 times VB. So 1.154 would be shifted on the other side and it would be divided by 500. And what do we get? How much? 433. Okay, 433. All right. So 433 meter per second. Okay, we leave the final answer, the very final answer in 2SF, but let me use these values. So this is your value for VB. How do we find the value of VA? Just put this value of VB over here, the easiest equation. So VA equals 0.577 times VB, which is 433. It would be decreased. So VA equals to what? 250. So VA equals to 250 meter per second. So this is the value of the second velocity, first velocity, and VA is 250 and VB is 433. So I'm going to leave both the answers in 2SF. So VA in 2SF would once again be 250. And VB, if I convert this one into 2SF, matter of fact, you can leave the answer in 3SF as well. No problem with it whatsoever. But I'm just going to do the conversion, and in 2SF it would be written as 430. So we get 430 as VB. So this is the most advanced question that you can have from the topic of momentum. And you see the method is same, but the prerequisites are the understanding of the components, the understanding of the vectors and their sign conventions. When do we add, when do we subtract, and the understanding of the fact that whenever we have something that is in 2D motion, we can break it down into two different axes, along x-axis, along y-axis, and from there we can safely apply the known equations of motion, or equations of momentum, or even the law of conservation of momentum. So that's it for today. See you on Monday. Take good care. Love with everyone.